Do you know why I love the number 925? Well, it's because if you remove the leading 9, the result, which is 25, still divides the original number. And it divides it with by a factor of 37. Right? 25 times 37 is equal to the number we started with, 925. So the question we're going to look at today is find all numbers n such that the leading term or the leading digit is 9. And when we remove the 9, what is left over divides n by a factor of 37. So when 9 is removed, the result is 1 over 37n. Okay? So we see that 925 is an example of one of these numbers. Are there more of these numbers? Pause the video and try on your own, and then come back when you want to see my solution. Okay, welcome back. So let's suppose that n has m plus 1 digits. Okay, so it's going to be an m plus 1 digit number. So we could write n as 9 times 10 to the mth plus some number L. Okay, where L has m digits. Maybe some leading zeros, but we'll say some leading zeros to make it m digits. It doesn't have more than m digits, or else n would have more than m plus 1 digits. Okay, and we want to satisfy this second condition. Says that L times 37 gives us n. Or another way to write that is n equals 37L. Okay? Well, we know n is 9 times 10 to the m plus L, and that's equal to 37L. And let's rearrange this equation. We could subtract over the L. And now let's divide by 9. So we have 10 to the m is equal to 4L. Okay? And now we could get L by itself. So L must equal 10 to the m over 4. We could factor 10 to the m as 2 to the m times 5 to the m. So this is equal to 2 to the m minus 2 times 5 to the m. Okay, and since 2 and 5 are relatively prime, and L is a whole number, we know that m has to be greater than or equal to 2. Okay? But other than that, there's no other conditions. So L could equal, well, let's take 2 factors of 5 out so they have the same exponent. 25 times 10 to the k for k equals 0, 1, 2, and so forth. There's no restrictions. So the numbers that satisfy our two properties, well, when k equals 0, that would tell us L is equal to 25. We still have that leading 9, so 925 is the smallest. The next one would be 9,250, 9,002, or 92,500, and so forth. Every time you add a 0 to the end, it's another number that satisfies these conditions. And these are the only numbers that satisfy these conditions. Pretty neat. So you could play around with other questions like this. What if we didn't have 9 as our leading coefficient? What numbers could you get? I'm not going to answer that now. That's something you could try on your own. Well, let me know what you think. I thought it was a pretty neat question. If you like these types of questions, I'm happy to do more of them. All right. See you later. Bye-bye.